Good morning, students. Today we'll discuss IUPAC nomenclature of cyclic organic compounds, all those cyclic organic compounds which have a ring of carbon atoms. Firstly, we'll discuss organic compounds which contain a closed ring having all carbon atoms, which are further classified into two types: alicyclic compounds and aromatic compounds. So what are alicyclic compounds? Alicyclic compounds may contain one or more all carbon rings which may be either saturated or unsaturated, but they do not have aromatic character. Actually, all those saturated or unsaturated rings which do not have a planar structure or which do not have conjugated sigma and pi electrons, they are classified into alicyclic compounds. Alicyclic compounds may have one or more side chain of straight carbon atoms or branched attached with the ring. So alicyclic compounds are given the parent name as alkane if they are saturated, or if they are unsaturated then alkene and alkyne, with inclusion of one primary prefix cyclo. It's very important to remember the name is same as given in unsaturated and saturated hydrocarbons, except this difference of prefix which is to be added in cyclic compounds as cyclo. So all saturated rings having alicyclic structure are classified as cycloalkanes, and they have a general formula CnH2n. Next, let us see now different alicyclic rings. The simplest cycloalkane, or the first member of cycloalkane series, is cyclopropane, having a ring of 3 carbon atom which can be represented by a trigon, and the name is cyclopropane. The next compound is a ring of 4 carbon atoms with all single bonds which can be represented by a square, and its IUPAC name is cyclobutane. The next compound is a ring of 5 carbon atoms. The formula is C5H10, which can be represented by a pentagon, and its name is cyclopentane. The next one in the series, a ring of 6 carbon atoms, all single bonded, and the name is cyclohexane. So in this way, all saturated and unsaturated rings which have or which do not have planar structure are classified under alicyclic compounds. Next, if such rings have a side chain attached with them, so if the side chain contains the number of carbon lesser than the ring, the parent name will be given to the ring. For example, in this compound there is a chain of 1 carbon atom, methyl group. The name of this compound will be methyl cyclopentane. In the next compound, here is a ring of 6 carbon atom with a side chain of 2 carbon atoms. So again the name will be given to the parent name will be given to the ring. The name is ethyl cyclohexane. Next is if the side chain contains equal or greater than the number of the carbon atoms that are present in the ring. मतलब रिंग में जितने कार्बन है अगर उसके इक्वल कार्बन चेन में है या उससे ज़्यादा है, then accordingly the name parent name will be given to the side chain. This is according to the previous rule of IUPAC. Recently IUPAC has changed recommendations. The name will be 1-cyclohexyl hexane, and the next one is 1-cyclopropyl butane. Next is if a ring contains more than one substituent, then the numbering should be done in such a way that the sum of locants must be lowest. For example, in this case, the correct way of numbering is the right hand side, in which both of the substituents are getting lowest possible positions. And the name of the compound is 1,2-dimethyl cyclohexane. If alicyclic compounds have more than one different substituents, then the naming should be done in alphabetical order. For example, in this case, ethyl comes prior to methyl in alphabetical order, hence the name is 1-ethyl-2-methyl cyclohexane. Numbering में preference alphabetically देनी है. But in case if two branches are getting lower position as compared to the one branch which is alphabetically prior, but in this case we'll give numbering to the methyl groups, because two methyl groups are getting lowest, some rule apply हम करेंगे and we'll give lower number to methyl groups, and the name would be 3-ethyl-1,1-dimethyl cyclohexane. If the ring contains a functional group as shown in this figure, then the name of the functional group is indicated by adding secondary suffix or secondary prefix, as we have discussed under the topic dysfunctional groups. For example, here you can see this ring contains hydroxy group. The name of this compound would be cyclopentanol. Here you can see that aldehyde group is present, which is directly attached to the ring, but this carbon of aldehyde group cannot be included in the ring. Here the secondary suffix L will not be used, rather carb aldehyde will be used, and the name will be cyclopentane carbaldehyde. So all functional groups like COOH, CN, cyanide group, carboxylic acid, suffix will be changed if these carbons cannot be included in the ring or the chain. If a functional group is present in a cyclic compound and a multiple bond is also present, then if the functional group is in priority order, that means if it is a principal functional group, then preference will be given to that group and then multiple bond. For example, the name of this compound is 5,6-dimethyl cyclohex 2-ene-1-ol. Here preference is given to hydroxy group and then multiple bond. But in case the group is functional group is considered as a substituent like chloro, nitro, ethoxy, alkoxy, in that case the preference will be given to multiple bond, and the name of the next compound will be 3-chloro-cyclohex-1-ene. Here preference will be given to double bond. Next, if a functional group is present in the side chain, means ring में कोई functional group directly attached नहीं है, but functional group is present in the side chain, then the parent name will be given to the side chain and ring will be given as prefix cycloalkyl. For example, here functional group ketone is present in the chain and a ring of 6 carbon atom is attached with 4th carbon, because numbering will give to that side from where the functional group gets the lowest position. Hence the name would be 4-cyclohexyl butane 2-on. When a compound contains a functional group in principal functional group in the chain and the ring contains a multiple bond, the name is given in this way. The number with the carbon of the ring which is directly attached to the chain will be given the number 1, and the name will be 3-cyclopent 3-enyl butanol or butane-1-ol. And if ring and chain both contain functional groups, then the functional group which is higher in priority will be given preference for parent name. For example, here ring contains hydroxy group and chain contains carboxylic group, and carboxylic group is of higher preference, so the name of the compound will be given as the derivative of the ring. the derivative of the parent chain, and ring will be given the name as prefix. So name would be 3,4-hydroxy cyclohexyl butanoic acid. Next compound, you can see that ring has a principal functional group carboxylic acid and chain has a minor functional group hydroxy. So in this case, the preference will be given to the ring, and the name of the compound is 4,2-hydroxyethyl cyclohexanoic acid. Next, after discussion of alicyclic compound, the next important topic is naming aromatic compounds. So aromatic compounds are those cyclic compounds in organic chemistry which have one or more planar rings in their structure, and these planar rings, a most common aromatic compound which is called the parent of the organic chemistry is benzene ring. So this benzene ring must be present in all organic compounds, and this benzene ring has a 6-membered carbon ring having alternate single and double bond arranged in such a way that it is overall a planar structure, and it shows resonance. Understand the representation of benzene ring. It can be presented either by putting 3 double bonds alternatively, and as due to resonance effect, these bonds are not fixed at a you can say delocalized pi electrons are there. Hence, the better representation of benzene ring is it is shown by a circle inside the hexagon, which represent delocalized pi electrons in the ring. Now, other aromatic compounds which have more than one benzene ring are naphthalene, anthracene, phenanthrene, benzopyrene, etc. Next, how to name aromatic compounds. If the compound contains benzene ring, a substituted benzene ring, and if the substitution of normal alkyl group for which the prefix alkyl is to be added to the word benzene, as IUPAC has recommended the name benzene for this simplest aromatic compound, and all compounds are named as derivative of benzene. So here this first compound will be named as methyl benzene, and it is popularly known as toluene, and the next compound is called the name ethyl benzene. Actually, aromatic compounds are very much popular with their common names, and IUPAC has recommended those common names as well. For example, here the first compound having hydroxy group attached with benzene ring, the popular name which is recommended by IUPAC also is phenol. The next compound, one amino group is attached with benzene ring. The name is IUPAC name is benzenamine, but the popular name recommended by IUPAC as well is aniline. Next is nitrobenzene. Here we can see the 3 more aromatic compounds having functional group carboxylic acid, aldehyde and ketonic group respectively. The popular name of these compounds are benzoic acid, benzaldehyde and acetophenone. But the IUPAC names are, for benzoic acid, the actual systematic name is benzene carboxylic acid, as the carbon of COH group cannot be included in the ring. But the popular name is benzoic acid, and IUPAC has also recommended that name. Actual or IUPAC systematic name for benzaldehyde is benzene carbaldehyde, and for acetophenone it is 1-phenyl ethane 1-on. But IUPAC has recommended all these common names as well. Next, for halogen groups, halobenzene is the common name, and for different halogens, fluorobenzene, chlorobenzene, bromobenzene and iodobenzene are the name respectively. Next, if we have alkoxy or ether group attached with benzene ring, the name is methoxybenzene, but the IUPAC has recommended its common name as well, which is anisole. And if vinyl group is attached with benzene ring, the popular name is given as styrene, and IUPAC name is ethinyl benzene, and it is also popular by the name vinyl benzene. When a benzene ring is attached to a side chain which contains a functional group, सेम जैसे हमने एलिसाइक्लिक में किया, अगर साइड चेन में फंक्शनल ग्रुप है तब आपने बेंजीन रिंग को सब्स्टिट्यूएंट कंसिडर करना है एंड पेरेंट नेम विल बी गिवन टू द साइड चेन एंड prefix used for benzene ring is phenyl. For example, in first case you can see the name of the compound is 3-phenyl propanoic acid, as the phenyl ring is attached to the third carbon because the chain is numbered from the carbon having functional group carboxylic acid. And in second case, when benzene ring is attached with a chain of 2 carbon having hydroxy group at first carbon, the name will be 1-phenyl ethane 1-ol. Next is disubstituted benzene ring. If benzene ring contains 2 substituents, then 3 different positions are possible by changing the positions, and in trivial system these 3 positions were named by or were indicated by these 3 prefixes ortho, meta and para, and these are still used in common names, and these are very much popular prefixes which are used in organic chemistry for indicating relative positions of substituents. Ortho is used for adjacent carbon positions like 1 and 2. If substituents are attached with 2 adjacent carbon of benzene, then the prefix used is ortho. If relative position of substituents are 1 and 3, then the prefix used is meta, and if the 2 substituents are present at the 2 opposite carbon atoms in benzene ring like 1 and 4th position, then the prefix used is para. Here we can see that when first group is present at second carbon atom, then ortho, for third it is meta, for fourth it is para, again for third meta, and for second it is ortho. So whenever 2 substituents are attached at adjacent carbon atoms, the name used is ortho, as you can see here. And when 2 substituents are attached at 1 and 3 positions, then meta is used, and for 1 or 4 position para is used as prefix. So you can go through these different positions. Here we can see when benzene ring contains 2 methyl groups at different positions, all these 3 positions are possible in case of disubstitution. First one is orthoxylene, second is metaxylene, third one is paraxylene. Now we'll name such disubstituted aromatic compounds. First compound having 2 hydroxy group at adjacent carbon atoms, the name will be benzene 1,2-diol. In second case, 2 hydroxy groups are present at first and third, means we'll give number to that carbon which contains a superior functional group. Here you can see, but both of the groups are of same priority, so we can give number to any of these 2 carbon. So positions will be 1 and 3, or you can say meta positions are there. So benzene 1,3-diol will be the name of IUPAC name of this compound, and in this case benzene 1,4-diol. And in IUPAC name, in common system we can give the names ortho, meta and para for these positions. Next, if 2 different substituents are present, then in common system the name will be given in ortho, meta and para prefixes, but in IUPAC name will give first number to in alphabetical order. For example, out of bromine and chlorine, the number 1 will be given to bromine and 4 will be given to chloro. And next is if compound contains 1 major functional group, then the number 1 will be given to that group. For example, in the second case hydroxy group is the principal functional group, and in third case amino group is the principal functional group. The numbering will start from that carbon. Hence the name of second compound is 2-bromophenol, third one is 3-chloroaniline, and the fourth one is having 2 substituents, methyl and bromine. Alphabetically bromine will be given preference, and or in case if we consider this compound as a derivative of toluene, then name will be given 3-bromotoluene. Next, try substituted benzene ring. अगर benzene ring में 3 groups attached हैं, and then numbering will be given in such a way that lowest positions will be given to the number. But in this case, all these groups are symmetrically arranged. The name of the compound is 1,3,5-trimethyl benzene, which is popularly known by the name mesitylene. Next compounds you can see here have 3 substituted groups, but out of which one is a functional group, that is OH. Then the name will be given as 4-ethyl-2-methyl phenol, and the next one will be 2-chloro-4-methyl anisole. In both of these cases, the functional group is given preference over the substituents. Now, in case polysubstituted compounds, the numbering is given in alphabetical manner as shown. For first compound, it is 2-bromo-6-chloro-4-nitrotoluene. As whenever CH3 group is present in the methyl benzene ring, then the compound parent name is given as toluene. Hence, the numbering will be start from toluene from the carbon where CH3 group is attached. And in second case, the compound is the parent name will be given as benzene only, and the substituents attached will be numbered alphabetically: 1-bromo, 3-chloro, 2-ethyl, 5-nitrobenzene. I hope the naming of cyclic compounds is clear to you all. Thank you. Have a nice day.